Hello and welcome to this video explaining how to write text to an LCD, and after that we will go into how to utilize scopes and meters in your circuits. To get a better understanding for the LCD and how it works, I will explain the 16 input pins that connect to it. So from left to right it goes G and D, which is the ground, VCC, which is connected to the 5 volts pin on the Arduino board. The VO pin is often attached to a potentiometer, which will control the contrast of the display. The RS pin, which means register select, is the pin that decides what data we want to send to the LCD. If it is set to a low state or 0 volts, we are sending commands to the LCD, such as setting the cursor location, clearing the display, and turning off the display. If it is set to a high state or 5 volts, we are sending data or characters to the LCD. The RW pin selects the mode whether we will read or write to the LCD. Here we will use the write mode to send commands to data to the board. The read mode is used by the LCD when executing the program. The E pin enables writing to the data pins D0 to D7. Through these, we are sending data to either 8-bit or 4-bit to the board, and for this video, we are using 4-bit. When using 8-bit, you decide what the LCD should display with ASCII or binary code. A and K are anode and cathode for the LED backlight. For programming the LCD, I recommend using the Arduino Liquid Crystal library, which is a great resource to code the Arduino LCD. So here you can see the circuit we set up for this video. Basically, you have to include the liquid crystal, which includes the LCD library, into the code. And then you need to initialize the library with your preferred pin numbers, which we have done so here. It will look like it's actually writing. I will demonstrate in a second. So let's just upload this and run it. Here we are defining the pixels, which are consisting of 5 by 8 pixels on the LCD screen. So we are creating a custom character design and assigning each block to the pixels. So we're setting a pixel to 0 turns the pixel off, and then setting it to 1 turns them on. So for the smiley. And then we are setting up the numbers of columns and rows we want to use. And also we create the custom character and store it in its memory to 0. And the Arduino can hold up to 8 custom characters in its memory. And here you see the first print, which is an opening message to the LCD. We then clear the LCD and print "Welcome to our LCD tutorial." And then the delay goes on, and setting the cursor to the beginning of the second row, setting cursor, new cursor. All of this is basically just what we want the LCD to display. And to perform scrolling text, we need to change the position of the text on the display with a delay. We set the cursor to 40, and that sets it to the middle of the top. And then we set the cursor to the middle of the bottom row, and it writes the custom character we stored to memory slot 0, aka the smiley. And here you can see, thanks for watching. So next up we have the scopes and meters setup that I wanted to show you guys. This is actually quite simple. It's just a way to measure the voltage and ampere and such like going through your circuit. So what we have done here is just the standard use output 13 and then set it as output, you know. And we have just set up a simple loop here that turns the LED on and off, which is this thing right here. And we have measurements before the LED, after the LED. We also have a resistor in here so that you can see that. I'm just gonna upload and run it and show you guys what I mean. So let's go. So here you can see there is a delay of 1 second. So for 1 second, the LED is on and then it's off again. Yeah, now you can see it. So it's blinking. And as it blinks, the voltage changes. And then we're also using the oscilloscope to show the voltage change across the LED and in the pins. So yeah, you can basically attach this to anything. As you see here, it's attached to the 5 volts and just shows that there is 5 volts coming through the 5 volt pin and or between the 5 volt and the ground. It's really that simple. It's just to ensure that your circuit is set up correctly if you are in doubt that you have done something wrong. And you can play around with this any way you want. Thank you so much for watching and good luck with your Arduino programming.